Hello, welcome back to another of our lectures on basic math or basic algebra. Today we're going to be talking about correlations and trend lines. Now, a correlation is a mutual relation between two or more things. A linear correlation occurs when the data points seem to fall close to a line. Now, I have two examples here. So if we look at this first example, as you see all the lines kind of follow along this. And we could, if we so wanted to, draw a line between these points, and it seems to kind of follow through. Now, when it goes up like this is known as a positive correlation. And if you look at the second example I have here, the points seem to go down as we go towards the right. And you could draw your little line here, and we would call this a negative correlation. So one of the things that we need to talk about is that line that we kind of drew through. So that line we drew through is called a trend line. Or it's the trend line or the best fit line, and it's the line that can be best drawn through the data points. And as you can see in our example here, it doesn't touch every single point, but it seems fairly close to a lot of the points. Our second one might do a little bit better of a job being a trend line than the first one. But just to show as an example of what a trend line is. And trend lines can be used to make predictions. So a few different types of things that you might find correlations between would be things like height and arm span. You might consider a correlation between, education level and income, maybe your study hours and your grade. Another one, we have GDP and unemployment. You can consider the temperature outside and ice cream sales. We could also think of things like engine size or the size of a car and how much gas it uses up. So let's do some graphing to kind of get some ideas of how to develop trend lines and how to figure these things out. So I have here a set of data points. That is the arm span to height. And we see these different little sets of points. So we're going to use each of these as an ordered pair. And we're going to go ahead and let the arm length go along the x, and our height, we'll let it go along the y. So let's go ahead and take our graph here and label things. So we'll let this be the height, and this be the arm span. And if you look at this, the arm span starts at, the lowest value is 60. So since the lowest value is 60, we're going to go ahead and start our scale at 60. So we would normally draw a little squiggly here, and then we're going to call this 60. And our highest value, if you look, is 75. So we're going to go ahead and put that 75 down. 75 is right here. We're going to go ahead and put this, why not right here? So we have 65, 70, 75. And then our height, similarly, goes from the lowest point is 60, and our highest point is 74. So we'll go ahead and scale that the same way. So here's 60, 65, 70, and 75. And as you can see, the scaling is fairly equal with each little division here. And we use that so that we can get as accurate as possible. So let's start off with our first point. Our first point is 71, 72. So if we look at our arm span here, 71, we come just a little bit close to 70, we'll go just a little bit over, and it goes up to 72. So it should be right about here. Then the next one's going to be 64, 65. So 64, 65. 61, 63 is next. 61, 63. 65, 64. 65, 64. 60, 60. 70, 70. And 75, 74. So you can see there appears to be somewhat of a correlation here when you consider how the dots kind of go. And when you're drawing your trend line, you'll just kind of take, usually you would use something like a clear ruler, and you want to get the points to be fairly close to the line that you're getting. And it doesn't have to start from this corner. And if you look, looks like it goes like that. So if you look at this, you can see that this is a positive correlation between height and arm span. This would suggest that as you get taller, your arms should be longer. Likewise, if you have long arms, you should be tall. So that's how we would say that the correlation between height and arm span would be understood. So let's go ahead and work on another example. I'll go ahead and erase this. So I have here a second example with a few sets of data points, or a few data points here, and we have unemployment is represented by U, and GDP of a country is represented by G. So if we look here, we see as the unemployment goes down, our GDP seems to go up. So let's look at how that looks like on a graph. Our highest unemployment's 9.8, our lowest is 4.9. So we could do a scale of about 4 to 10. Or you could do 4.5 to 10, but then you'd have to split it up in an interesting way. I'm going to go ahead and do the unemployment on the bottom. So unemployment. And I'm just going to start here at 4. Come over here to 10. 5, 6, 7. Guess we're going to have to change our scale a bit. This is 10. This is 7 in the middle. 5, 6, 7, 8, 9. 9, 8, 7, 6, 5. So here we go. It's relatively well done. When you do this yourself, you should probably use a more accurate actual grid. And then we have our GDP goes from 15 to 18.7. So I'm going to go ahead and do a scale of 15 to 19. So GDP 15, 16, 17, 18, 19. So here I've got 15 to 19. The scaling's not quite perfect, but it's okay. So our first point says we have 9.8 and 15. So 9.8 and 15 is close to 10 and 15. So we'll just go a little bit here before the 10, go up to the 15, put our dot there. Then we have 9.1 and 15.5, 9.1, 15.5, then 8.3 and 16.2, 8 and 16.7, 6.6 and 17.5, let's be right about there, 5.7 and 18.2, and then 4.9, 18.7. So if we look at our graph, it seems that as we take our points here, it looks like it's kind of dropping downward. So this would be a negative correlation. And if we took our trend line and tried to do an estimate, we would probably do something right about there. So one thing to note is, as I said earlier, we said that there was a prediction that you could use the trend line for prediction. So if we looked at this trend line here, and we were to follow this line past the data points that we currently have, we would be able to draw something like that here and up here as well. Say, well, if the unemployment goes to 4%, then our GDP should be somewhere up here, somewhere closer to 20 billion. If our unemployment goes over 10, our GDP should continue to sink. And we should be able to say, okay, well, at 7%, our GDP would be at about 16.9. And that's what I mean by saying you can use these things to make a prediction. So the next thing to learn about that's kind of important that has to do with this is what's known as the residual. And the residual is the difference between the predicted value and the actual value or observed value. So we said over here that we could make predictions. And if we were to make a prediction off of, say, 8, then our predicted value for 8 should be down here, closer to 16.2. But it's at 16.7. So this difference between our predicted value and our trend line and the actual value, this is our residual. So let's look at an example of working with residuals. Suppose that your grade could be predicted, your final exam grade was predicted off of your overall grade before the final exam. And we came up with an equation that looks like this. So let's use this equation. We're going to say, well, this is the trend line's equation. And we would take 1.0138, multiply that by the overall score, subtract 4.1629, and that'll give us the predicted grade. So if we look at our first one's 72. And if we look at the predicted grade for that, we would say 1.0138 times 72. And if we put that in, that gives us 72.9936. And then we would subtract the 4.1629. Minus 4.1629. And this gives us 68.8307. So the predicted grade would be about a 68 or 69. And if we look at our residual, the actual grade is 73, and the predicted grade is 69. So our residual would be 4. Now, utilizing the same math, same formula here, and just inputting in these different grades to get our predicted grades, our predicted grade for 68 will come out to be 64.8. And if we rounded it to the nearest whole number, it would be 65. For this one, with our actual grade of 81, the predicted grade will be a 78. For this one, the predicted grade will be about an 85. And for the 78 here, the predicted grade will be about a 75. Now, take note that I did round all of these up to the nearest whole number. So if we look at our scores here and we calculate our residuals, we take the observed value minus the predicted value. So what we did here, 73 minus 69 is 4. 54 minus 65 is negative 11. 76 minus 78 is negative 2. 86 minus 85 is positive 1. And 75 minus 75 is 0. So here we have our different residuals. And if you notice, some of them are positive and some of them are negative. So when it's a positive residual, that means that the point is above the trend line. And if we look at our examples from before, we have some points that can be above the trend line. These would have a positive residual. And then if you look here, we have some of them that are negative. Those mean that those points are below the line. These points would have a negative residual. The residual does not necessarily have anything to do with the correlation. It has everything to do with the difference between the trend line and the actual points, not the direction of the correlation. And if you look here, we have one that's 0. That means that this predicted value is the same as the observed value, the actual value. So that's why there is a 0 residual. Now, if you have in this case with the grades, if we look at this 4, that means that this student did better than what was predicted. This student with a negative, these two negatives, means that they did worse than they were expected to do. This student did better than expected, and this student did exactly as expected. So, that's it for this lecture. Hope you've learned a bit about trend lines, correlations, and residuals. Good luck. I'll see you in the next video.